Hey everybody. Today we're moving on to still dealing with natural logs, but we're going to be talking with integration with integrals. Okay. We did derivatives of natural logs. Now we're going to do the integration. Okay. So we talked about the fact that the integral of a natural log is du over u, derivative of the inside over the inside. Remember, integrals are just like the opposite. They're the antiderivative. So really, it's just if I take the integral of du over u, if any case we ever get this, it's going to be equal to the natural log of u plus c. Now, what this is going to allow us to do is, I don't know if you guys ever realized this, but we never did it when we never did an integral. We just have x in the bottom, a power to the negative 1, right? The reason is because if I integrated this, right, and this was x to the negative first, I would have to add 1 to negative 1. I get 0, and you put yourself over 0. All right, so all the time we did substitution, we never had like u to the first on the bottom, which u to negative 1. All right, now we're able to do that using this. Okay, now you once again, you don't need to memorize this formula because here's your formula sheet. All right, and integral of du over u right here is the natural log of u plus c. All right, also looking over here on the left, the derivative of the natural log is du over u. All right, so all of this stuff is on this derivative integral sheet. Very, very important, very useful resource. All right, this is something if you're going to take calc courses again, this is a good little reference to keep handy when you go to college. Okay. All right, so let's go back to here. All right, so what we're going to do, this is just another way of being able to use substitution. All right, so we talked about doing last chapter, making u whatever's on the inside. Well, now we have a situation where if you have a fraction, try u as the denominator. It's not always going to work, but a lot of the time it will. All right, so for this first example, if I were to make u 4x minus 1, that means du would be 4dx. Okay. So all the same things that we've done in the past. You want all of du to be inside of our integral. We have a dx, we're missing a 4. So I can add a 4 to the top, which means I put a 1/4 on the outside, integral of, well, what's this? Well, that's 4dx, which is du. What's 4x minus 1? That's u. So I'm left with du over u. We don't do u to the negative first because then we end up with something like this. We get 0 at the bottom. We just use this. What's the integral of du over u? It's the natural log of u plus c. So my answer is 1/4 natural log, absolute value of u, but I'm just going to plug in right now, is 4x minus 1 plus c. All right, so that is our final answer. All right, 1/4 natural log, absolute value, 4x minus 1 plus c. All right, B, same thing. When you have a fraction, your best bet now is to try to make u, unless it's like you have something raised to a power or something inside. All right, another way of picking u is just whatever's in the denominator. Okay, so we're just adding basically to our repertoire of ways to find integrals through substitution. So if we have u equals x squared plus 3, du is then 2x dx. All right, now all the same stuff applies here. We need to have a variable. We can't add variables. So if I put the 2 in there, all right, I put the 2, all of this here is my du. Since I added 2, I put a 1/2 on the outside. All right, we get du is on the top, u is on the bottom. All right, and once you have this, nice and easy, just this. It's 1/2 natural log of u, which is just x squared plus 3 plus c. Done. All right. Students normally like du over u because once you have it, it's really a nice, easy integration. All right. Go ahead and try C on your own. See if you can get that one. All right. Now, all right. So if I make u the denominator, x cubed plus x. So then du is 3x squared plus 1. All right. And 3x squared plus 1 is already there, along with my dx. So I don't need to add anything. So I just get du over u, which is the natural log of u, and u is x cubed plus x plus c. And there's your answer. Natural log of absolute value of x cubed plus x plus c. All right. All right. Let's look at D. All right. Same thing. All right. U is, just block that off, is 3x plus 5. We're going to make the derivative of that, 3 dx. We need to add our 3. We get 1/3 integral. All of this up top here is my du over u. Once we see that, we just put the 1/3, and then we rewrite natural log of whatever the absolute value of our u is, 3x plus 5 plus c. And there's our answer. All right. Now, so for E, all right, so now we have a trig one. Okay, now we've done trig with substitution before, and we've done it so that if there was two trig functions like there is here, then you take the one with the higher, which would be secant. But that's not what we're going to do here. All right, for this one, all right, what's going to end up happening is you have a fraction, and it's not 1 over. We've done one fractions before, but what we're going to do is let's try to take. If I did take secant x, it doesn't work. Okay, and if you did, you would see it doesn't work. So when you have a fraction, an option we now have with du over u is to take u as your denominator. So what is the derivative of tangent? Remember, if you forget what your integrals are for that stuff, you can look at your integral sheet and you could figure out, oh, the derivative of tangent is secant squared. All right. So the derivative of tangent is secant squared x dx. We don't have to use chain rule because it's just x and anything else. Well, what do we have here? Oh, there is our du. That's all of our du. So I don't need to add anything. It's already there. Du over what's tan x. That's our u. So we have the answer of the natural log of what was u. Well, u is just tangent x. Natural log of tangent x plus c. And there's our answer. All right. All right, go ahead and see if you guys can. Well, actually, you know what? Let's do this one together. All right, so block it off. Our u is going to be, once again, the denominator. All right, if you have a fraction and nothing else is obvious, and other things would be obvious. Even a fraction, if you have some quantity raised to a power, you put u as whatever's inside. All right, if it's not obvious that it's not the denominator, then it's probably the denominator. All right, so the derivative of x squared plus 2x is 2x plus 2. Okay, now, got to be a little careful here. I want 2x squared plus 2 dx. I have x plus 1. What can I do to x plus 1 to get 2x plus 2? Well, I can multiply it by 2. All right, so I'm adding a 2 here. So what I can do, which that's perfectly acceptable, I'm multiplying everything by 2. The whole top by 2, which means I'm going to put a 1/2 on the outside. Now, if I did all this, that is my du over u, and that's going to give me 1/2 natural log of, what's u? X squared plus 2x plus c. So there's my answer. All right. Now, take a look at G. Okay, we have natural log of x, that being cubed all over x. All right. All right, so just because we have a fraction doesn't mean if I made u is equal to x, right, then I would make du would just be dx, and then I'd be left with the natural log of u cubed. That's no good. All right. So looking at this is what kind of talked about in the previous problem. We have something being raised to a power, don't we? Well, it's natural log of x. So let's make that our u. All right. It's not just because we have a fraction doesn't mean that bottom's always going to be our u. If you see something that is being raised to a power, that's probably going to be it. What's the derivative of natural log of x? Well, the derivative of natural log of x is du, derivative inside, which is just 1, over the inside, which is x. Well, what do we have here? We have 1 over x dx. All of that is my du, right? X, 1 over x dx. So I have du, and I'm left with u cubed. So this is just u to the 4th over 4 plus c, and we substitute u back in, so it is the natural log of x to the 4th power over 4 plus c. All right, so I threw this example in there just to show you that it's not, just because it's a fraction, we'd always make u what is in the bottom. All right, before I forget, we're not doing that one right now. All right, go ahead and try h. We're going to do 2 more for today, and then we're going to call it a day. All right, so try h right now. All right, so hopefully you made u x squared plus 3. The derivative of that is 2x dx because the derivative of 3 is 0. We added 2, and I have my 2x dx, which means my 1/2 goes on the outside. All of this is my du over u, and du over u is the, well, put the 1/2, don't forget about the 1/2, whatever if you put it outside. Natural log of the absolute value of u, which is x squared plus 3 plus c. All right. So hopefully you guys got that and are understanding this okay. All right, so the last one we're going to do, and a lot of the rest of this is going to be a lot of trig stuff, but I wanted to show you something here. Integral of tangent, all right? Now, what is tangent? Tangent is sine over cosine, right? Tangent sine over cosine. So if I made it like I've done this, we can make u cosine x, right? We can make the derivative of cosine x negative sine x, all right, dx. So sine's already there. I'm sorry, there's a dx there already. All right. So the only thing I need to add is a negative. So if I add the negative in there, all of this I can replace with a du over u. So du over u, that is natural log, notice I have the negative out there, of what's my u? U is cosine x plus c. All right. Now, good news is you don't really have to go through and show me all that work because of this wonderful, formula sheet. Look what we have here. All right. We have negative, the integral of tangent is negative natural log cosine u, in this case u is just x, plus c. All right, that's exactly what we prove why it's the case. But from now on, if you just see the integral of tangent, use this formula. All right, so that's why, see all these ones over here that have these natural logs in it for the integral of tangent, cotangent, secant, cosecant? Well, they're all for similar reasons that we just did previous. But you don't need to go through and do all the work that we did for this one. If you just see the integral of tangent, you would do natural log of this right away. Now that's only because we have x. You do have to do some work with this because there's something after it. All right. And next, let's just do this one and then I'll end it. We treat the same rules we had for other trig. There's one trig function. What do? You take whatever comes after it. So you do 5x. The derivative of 5x is 5 dx. You add in a 5. So it'd be 1/5 integral of tangent u du. We would then go look at our formula sheet and it would tell us the integral of tangent u is the natural log of cosine u, which u in this case is 5x, plus c, and you are done. All right, so we will review this the next time. All right, I'm going to give you an assignment. We're just practicing basically non-trig ones, and then we're going to go through, as you can see, a bunch of trig. These formulas here are all on your formula sheet, so we don't have to worry about memorizing any of those, and we'll go through that next class. And then we'll probably do 2 days of review and then have your quiz. So your quiz will not be until next week. You won't be having a quiz at all this week at all. All right. I hope everyone is hanging in there, and I will be talking to you guys soon. All right. Have a good one.